Hey everyone, and welcome to this lesson in Algebra 1. This one is section 1.2, an introduction to functions. Again, if there's anything that will help this lesson, go ahead and put it in the comment section, and I will try to implement it next video. If you have any questions over anything within this video, again, go ahead and ask, and I will take a look in the comment section and see if I can answer it. Now, let's look at problem one. I always feel that the best way to learn is through explanation and also examples. So, question one says a student rode their bike from school one afternoon to their job. The plot shows the distance in miles from the student's school to their job, right? The first part of the question asks, what is the range of the function? So, range here. And then the second part is, what is the domain? So one thing that you have to know, what is range and what is domain, right? Domain, let me take a step back. What is a function in general, right? A function can be seen as something that has an input, whether it's one variable, like in lesson 1.1. It could be two variables, it could be five variables. However many variables, you have this input and then you get an output. Okay. Now there are different rules to what is classified as a certain function or maybe a certain type of function. So for every input, there's, I guess in a sense, a single output, right? So if you have something that goes like this, and you have something else like maybe that, right? Is this a single function, right? So you have your input, which is normally your x-axis. It depends what you're solving for. In Algebra 1, I usually have equations that say y of x or maybe f of x, right? A function of this input equals, I'm going to make something up, x squared plus 2. Or the same thing, this is just saying function of the input of x gives you is equal to x plus 5. All right, some function here, right? But for these functions, the inputs given have a single output. Okay, now what is the range? The range is the list of y values of a function. So looking at this plot, we have time on the x-axis and we have distance on the y-axis. There are certain things that you should pay attention to. Zooming in here, and forgive my poor drawing, but what is the range of this function, right? So we start at time equals 0. The students, 8 miles, miles from the student school to their job, whatever, 8 miles to go to their job, right? And then in 8 minutes, they travel from 8 miles away to, let's say, 2 miles away. And this is not filled in. Okay? Now, the range details the list of y values of this function. So, for this problem, the list of y values are the output of this function. This line, I'm going to make up a function, but it could be equal to negative x plus 8, right? And that would be equal to like f of x. Or you can say y equals negative x plus 8, f of x, a function of x equals negative x plus 8. I don't want to overcomplicate it, but the range is going to be the output of this line. Now, looking here, a question, one of the answers may try to confuse you and tell you that the range is 8 to 2, which is true, but it's not entirely true. Since this isn't bubbled in, it's not included within the domain or range of this function. So it's everything up to this point, right? This dot means that this value here is included. So at the end of these lines, you can either see a circle here, or you can see a filled in circle here. This one means that the value that this describes is included, right? And then this one means that it's not included. So ultimately, what is the range of this function? We have 8 here, and we go all the way down to 2, right? So this could be written as y is less than or equal to 8. And I note I say less than or equal to because all the y values are less than or equal to, as in this filled in dot is included within the range. But y is greater than 2. It is not greater than or equal to 2 because it's not included. This dot that is on 8, 2 is not included in this function. So whether they walk up to 2.00001 miles away, 2 is not included. Okay, and the same thing for what is the domain. Range here is equal to this. The domain is all the x values of this function. So looking at the x-axis, which is time, we have 0. The x is including 0 and does not include 8. So we would say x is greater than or equal to 0, but less than 8. It does not include 8, again, since this is a circle and it's not filled in. Okay, so going to the next problem. Ooh, sorry, let me just do this. So I still haven't gotten that down. Problem 2 states the cost per uniform on the sports team is given by the following equation. Cost equals 15x plus 35, where x, the input, is the number of uniforms purchased. If there are at least 10 players, but not more than 15 players, what is the domain of the equation, right? So this is saying that the cost that the team's going to spend is equal to 15x plus 35. What is the description of this? X is the number of uniforms purchased. So they're saying it is $15 per uniform purchased, X, plus 35. So this 35 could be a registration fee, a team sign-up fee, whatever it is, or just a baseline cost. So the manufacturer makes money off of the jerseys, right? And this whole thing can be rewritten as y equals 15x plus 35, or even f of x equals 15x plus 35. They are saying that x, if there are at least 10 players, but not more than 15 players. So at least 10 players, that means there can be 10 players, but not more, as in no greater than 15, but 15 is included. What is the domain of the equation? So looking at the wording, they are saying that the amount of players is at least 10, so it's greater than 10, but it could also be 10. And not more than 15 players. So x is less than or equal to 15. So that is the domain. Not part of the question, but if they ask, what is the range of this of the equation here. What you would do is say y, same thing, since you are including these values inside of the domain or inside of the equation, right? So you're saying that your inputs can be 10 and they can be 15. You would do f of 10 right here, and then you would do f of 15. So example would be 15 times 10 plus 35, and then you would have 15 times 15 plus 35. All right, well, I hope that helped. Again, if there's any questions, any input that you have on how these lessons can improve, or if you have other questions, maybe your own homework or anything like that, go ahead and put it in the comment section, and I will take a look. Again, thanks for watching, and until next time, y'all have a good day.